Hey guys, in this video I'll show you how to calculate frequency, wave speed, and wavelength. I'll identify the units that you should use when you give your answer, and I'll talk about what you should look for when you're given a question. What words will clue you into what they're asking for. So the very first thing I want to go over is how to calculate frequency. To calculate frequency, you use the formula F equals 1 over T. That's to say, frequency equals 1 divided by the period. All right, remember that capital T is used to represent period. Okay, so if you are given a situation where you're asked for the frequency and you're given the amount of time that it takes for a wave to reach one point, then that means you use this formula. Okay, the giveaway is that it's asking for frequency, and then it gives you the time that it takes for the wave to travel the wavelength, okay? And you put the time down there, okay? You put the time in the denominator. You just do 1 divided by whatever that number is in seconds, and that'll give you your frequency, okay? So frequency, the answer to this, when you find your answer, it'll be some number, maybe let's say it's 5, and you will give the unit of hertz, so 5 hertz. So whenever you find the frequency, make sure you write hertz after your answer, and it can be abbreviated HZ. Let me find the right pen. All right, so when you get your answer, it's going to be in hertz, HZ. Frequency is in hertz. Okay? Let me write that a little bit more clearly. So on the test, you'll also be graded on whether or not you have the correct unit. And so whenever you calculate this, when you're asked for frequency and you calculate it, give your answer in hertz. Okay, next, how to calculate wave speed. Well, wave speed is equal to V, so the formula for it is V equals F times lambda. That's to say velocity equals frequency times wavelength. Okay? So, when you have one of these problems, you'll literally be asked to find the wave speed. So you just need to remember that the formula for wave speed is this: V equals F times lambda. So you take your frequency, whatever the frequency is, you'll know, if you look at the problem, you will know they're talking about frequency if they give you a number in hertz. So if when you read the problem and it asks for wave speed and it says a vibration of such and such amount of hertz, 5 hertz, you know that's your F value, okay? And then you multiply by lambda. All right, lambda is the wavelength. A wavelength is a distance. So in a problem, if you're asked to find wave speed, they'll include a frequency in hertz and a distance in meters or inches. I'll keep it simple so you don't have to convert, and I'll keep it in meters, okay? So this will be a number that is in meters, and this will be a number that's in hertz. So look for that in the problem. And the unit for this, when you finally find your answer, when you do the multiplication, you find your answer, the unit is meters per second. All right, we're talking about speed, and we all know that speed is meters per second. All right? So wave speed is in meters per second. Now you may also be asked to calculate the wavelength, all right? So all you really need to know is the formula for wave speed, and you'll know the formula for wavelength. Look, this formula is derived from the formula for wave speed. All I've done is I've taken the formula for wave speed and I've divided both sides by frequency, and then I get lambda equals wave speed or velocity over frequency. So if you want to find the wavelength, it'll literally ask you to say, what is the wavelength? So when you hear what is the wavelength, that means you use this formula. Lambda equals speed divided by frequency. So you'll know that you're given a speed when you're given a number in meters per second. You'll know you're given a frequency when you're given a number in hertz. And all you have to do is you take that number that's in meters per second and you put it first and you hit divide, and then you put in the number that's in hertz. And that's how to calculate wavelength, okay? Now the wavelength, the unit for wavelength, this is talking about distance. The unit for wavelength will be meters. So your answer will be in meters, and you'll just write an M for meters. All right, so for units, let's review the units again when you get your answer. Frequency, your answer will be in hertz. Wave speed, your answer will be in meters per second. And wavelength, since it's a distance, your answer will be in meters. I want to rewind a little bit and go back to frequency. Frequency shows a very important point and a very important concept in that the period of a wave is inversely proportional to the frequency. That means if you have a wave that has a small period, then each up and down wave is really close together. All right, this is high frequency. If you have a lot of waves close together, that's high frequency. If you have a longer period, then you have a low frequency event. So the waves would be more spaced out since it's a longer period, and then it's low frequency. That's what an inverse relationship means. So if you have a large period or a high period, you have a low frequency. If you have a low period, you have a high frequency. And that's what this equation is sort of a symbol of that concept. All right, go ahead and move on to the review guide. I changed my mind since the last video. I'm just going to include one page will be a study guide of the concepts, and the next page will include the formulas for the calculations. You won't have to do any work. I might put some practice problems on there, but the practice problems are optional if you just want to get more practice. Really what I want you to do is just to study. Study the information, make sure you understand it, and then you'll take the test tomorrow. If you feel like you need practice on the math, complete the practice problems. I'll take a look at what you do, and I'll provide corrections if you need them. All right, go ahead and take a look at the study guide and take some time to study it. The test is tomorrow.